Okay, great. The stream is switched over, and the guys in the YouTube chat box will let us know soon. For the confirmation, please. Okay, welcome to 2.0 implementer call number 14. We have a lot of us and a decent sized agenda, so we will keep the client, although we have a lot of exciting client updates, we'll keep them brief and try to get into some of these agenda items. And we will start with testing. I've been doing a lot of work on testing. One of the big updates coming in v0.5, which is to be released later today or tomorrow, is that the spec is now fully executable, the Python spec. And we've done some work to pull that out into like an executable file and run some tests against it. And we now have some state tests against the actual executable spec, which is, I think, a major achievement and going to allow us to all actually be running the same code soon. Cool. So I shared a sample of that file in the Gitter last night. And I'll be getting more of that together today and tomorrow as we release the v0.5. This conforms to the standard that I posted to the 2.0 generators repo a few weeks ago. Some of the details are probably still up for debate, and but now that we have kind of a general format together, we can iron out some of those details in the coming days. Cool. Any other testing updates?
Yes.
Yeah, Shen, go ahead.
Okay. Yeah. Thanks to Dimitri and Paul. The shuffling test is updated to 0.4.0, and it's just released. That's all. And BLS fixed tests will coming soon.
Great. And I believe the shuffling algorithm has not changed between 0.4 and 0.5, so that can remain stable if we merge that. Okay, any other updates? Great. We will move on. How about client updates? Pegasus, you want to start us off?
Yep. This is Jem from Pegasus Artemis. So we successfully integrated LMD Ghost to our state processor. We started working on our honest validator client implementation, and currently we can successfully generate blocks, which in turn our beacon nodes successfully run the state transition on. We implemented a data provider inside our client to output information to CSV or JSON files. We started profiling our code to look at performance bottlenecks and visualize the call graph. And lastly, we're working with Zach Cole from Whiteblock and Anton Tulum on getting a testnet set up and implementing the Hobbit's wire protocol.
Great. Thank you so much. How about Prismatic?
Yeah, hi guys. So we're mostly working on validator runtime right now. So we're testing and debugging the validators can correctly propose and attest throughout their lifecycle. And Beacon node can correctly process slot, block, epoch. We fixed a few bugs here and there, and they're mostly related to boundary conditions. And then we also started testing multi-node setups. By multi-node setup, I mean there's 4 validators connected to one beacon node. There's other 4 validators connected to another beacon node. And then we make sure the sync can work, and then the validators can fail over if one beacon node fails. So we will have more update on that next time for the testing result. And we also implemented LMD Ghost framework. So we have some preliminary batch numbers, and we're looking to optimize it. So we're looking at Protos repo since he did a great job on that. other than that, yeah, basically just testing. Yeah, that's pretty much it.
Great, thank you. How about Yeast?
So we've kind of taken a break from working on the actual client. We're currently looking into implementing libp2p in Swift so we can start working on networking stuff.
Cool. Thank you. Parody.
So for Parity, so right now we are mostly focusing on the testing. I think we will continue to do that at least for recently. So the rationale is we still plan to do a lot of refactoring for the runtime, but we kind of want to make sure that our refactoring is correct and we don't accidentally break things. Of course, matching the whole state test is our end goal, but right now we are just trying to do unit test. So we're basically just manually getting the Python spec file and try to run them and gather the output and then put that function, the output of the Python file into our Rust code. It mostly works. And we also try to, this is not related to testing, but for the other thing, we are trying to move the adapter layer for our substrate from within the execute block, from above the execute block. So the execute block function can be like standalone without substrate. So this can hopefully make the runtime more flexible in different situations. So that's for us.
Awesome. Thank you. How about Lodestar?
Hey, sorry. Yeah, so nothing like major. We pretty much scaffolded all of our like auxiliary stuff inside the client, like the database, like kind of where our P2P stuff's going to handle, and all that other good stuff. We finished up all our state transitions, and we're going to start like actually testing everything kind of with a fake 1.0 1x deposit. We're pretty close on getting libp2p done in JavaScript. We're just waiting on a few PRs, and hopefully once those get done, we have a better understanding of like where we stand with that. And we're working towards we're starting up the validator client right now. And other than that, it's kind of where we're at.
Awesome, thank you. Harmony.
We've been working on a simulator and released its first version. This version is based on the spec as is. The only optimization we have there is improved shuffling algorithm. Simulator works well with hundreds of validators, but with thousands of them, simulation becomes insanely slow. This is basically because everything is running in a single thread so far. The next step would be to make it work with, let's say, 50,000 validators, and do some benchmarks on these big numbers. This is a work in progress so far. During benchmarks on a small number of validators, we have found several bottlenecks and already sorted them out. These bottlenecks are not even related to the spec, it's some issues with our implementation. For those who are interested in trying out a simulator, I'll post a link. Any feedback would be much appreciated. Also, we started to get integrated with the testing suites, made a small PR that fixes shuffling test generators, and also encountered an issue with shuffling swap semantics. I guess we will talk later about that. So that's pretty much it.
Great, thank you. And if you've implemented the spec as is, as you said, are you caching the shufflings per epoch?
No.
Okay,
There
that's
is no
probably the most major bottleneck. One of the most major bottlenecks, and probably the easiest thing to resolve at this point.
Yeah, that's what we have already discovered. Yeah.
Cool.
And okay.
Okay, thank you. Let's see, Lighthouse.
Yep. So we've been building out our runtime, working on syncing. We've been trying to get kind of the phase 0 wire protocol in, very roughly aware that it's a moving target. We did a bunch of benchmarking. So we made a document. It's in the PM repo, like the issue for this call, which has a whole bunch of information and hopefully it's useful to people that are trying to optimize. We did 16K, 300K, and 4 million validator benchmarks. We've got a full-time resource on the validator client. We've got a part-time resource working on an efficient block operations pool. That's it for us.
Great, thank you. Nimbus.
Hi. So let's start with libp2p. We've been working on libp2p NIM to replace Go daemon. So on that PID pure store are done. We are considering bounties to progress further, and we're working on interfaces and fixed or discovery and whisper testing. Now regarding libp2p in the beacon chain using libp2p daemon. So we right now use the RLPX, but we also have a simulation that kind of work using a libp2p daemon, and we will provide an option to select both RLPX or libp2p for testnet. On sync for the beacon chain, we have an open question on handshake, and we are using RLP serialization for the wire protocol that we implemented, and we want to kill RLP in that. Regarding the state, in the past month, we froze our spec to 0.3. We moved to 0.4 this week, and we are eagerly waiting for 0.5 so that we are able to compare our block hashes with the executable spec. And we've been working on rough optimization and to remove quadratic behaviors that we found in the beacon state. And in terms of preventing bug, we have been using a NIM type system to create like epoch and slot types and have the compiler tell us that we are mixing both. So that's quite nice. We have a dev update blog post coming soon. It's been written and it's under review. And as you know, last week I did a talk at ETHCC on testing and simulation. So I will provide the slide on the sharding GitHub channel like in 2 minutes. And lastly, our big item for the week was integrating a naive LMD ghost in our simulation, because before we were using some kind of fork choice called latest resolve block. Like the latest block we received, we considered that it was the one to use. And it's working fine. We have a lot to do to optimize it, but we are already considering Proto Lambda's implementation and also the bitwise LMD ghosts. So next week we'll be on that and also on testing.
Great. And to be clear, bitwise LMD ghost is not exactly the same. It generally returns the same results, but in certain corner cases might return a different result. So that's something we would only all use probably as a group decision rather than as a one-off.
Yeah, I've seen that, but I think it's good to have like to know the performance trade-off.
Oh, absolutely.
So yeah.
Cool. Great.
You should be able to
Yep.
convert bitwise ghost into standard LMD ghost quite easily. You get the same optimizations, just FYI.
Cool.
In my repo, so you find that the implementation from Vitalik for LMD ghosts, but then basically without the parts that are bitwise LMD ghost specific.
Cool. Okay, Trinity.
Hello. So this 2 weeks we are still working on the spec syncing, and now we are targeting at the version 0.50. Hopefully that's the one that we can finish the spec syncing. And on the other side, the ongoing updating is that we've moved the BOS module to the PyECC library. And since the BOS signatures verification is like our biggest bottleneck of in Python area, so I'm trying to isolate it as we can. And also the libp2p integration is still ongoing. Beside the Trinity implementation, about there's two interface updates of the deposit contract. And so if you using the latest deposit contract library, deposit contract repository, Eth2.0 has been merged this week. One is the PR 21. We updated the deposit event interface, and another one is the 22, which updated the Eth2 Genesis event interface. Another thing that I want to give update is that since there's a spec proposal about changing the hash functions to SHA-256, Viper team is very supportive. They've added the SHA-256 built-in function to the latest Viper release. So yeah, if that's something we are considering, it's okay to change it in the contract. Thank you.
Great, thank you. Cool, did I miss anyone? Great, I think I got it. Okay, next I'm going to read a quick update from Raul at Protocol Labs. He says, we're working to add deprecation notices to the areas of the spec that are outdated. We're making significant strides on the new docs.libp2p.io and writing a non-normative walkthrough of the libp2p stack that everyone can use as a reference, and engaging in various debates on GitHub. Raul is generally very responsive if you have questions and things, and he'll probably join us next time. Thanks, Raul. I threw the Lighthouse benchmarks update on here. Was there anything of note that you didn't get to in the Lighthouse update that you wanted to share with us?
Regarding the benchmarks?
Yeah.
Yeah, I guess the trap for a lot of people is there's a lot of like ON squared stuff in there. Like if you just implement it straight out of the spec, like especially inclusion distance, so it's pretty obvious. But if you just copy it out of the spec, that can be a massive slowdown. And we did a lot of parallelization with all the processing, and that saved us a fair bit of time.
Right.
Yeah, I guess one of the interesting things we did was do rewards processing as a parallel map to validator balances, and the spec was really well designed for it. But yeah, if you want to check it out, there's maybe some information for implementers in there. And
something you were surprised about was that decompressing a point in G1 costs the same amount as aggregating a point, 2 points in G1, correct?
Yeah, that's right. So we kind of had this problem where we wanted to, when we're processing a deposit, we want to see if a public key exists in the validator registry or not. So we were keeping a map of building a hash map of pub keys to validator index. And then when we were doing that, we found that, going to bytes was really slow. So then we were like, oh, well, why don't we store the just instead of storing it as like the point for our BLS library, we'll store it as uncompressed bytes, which made our hash map really fast, but then made our SSZ serialization really slow because then we had to like compress it. Yeah, so we kind of found an interesting thing. I spoke to you, Danny, about it. Was just kind of wondering why that we're compressing the public key bytes when it seems like everyone's going to need it in uncompressed form anyway.
Vitalik, did you have a comment on that?
I think the only comment I had is that I don't think it would be a good idea to alter the spec to store uncompressed points, basically because that would just require us to standardize serialization for uncompressed points in addition to serialization for compressed points.
Yeah, sure.
Right, but good to know.
Like clients, especially given that the uncompressed points doesn't actually store, like it doesn't really get changed or accessed. Like it might even be reasonable for a client implementation to just basically as soon as you get the uncompressed point, you would just hash it, store the hash for like tree hash purposes, and then immediately uncompress it and store the uncompressed version.
Yeah, that's what we've started doing basically. We just maintain that hash map of deposits, so we don't have to just do it all at once and burn time. So it's not a big deal for us anymore.
Yeah. One kind of other more general thing to keep in mind, by the way, as we start like exploring different efficiency trade-offs, is like in this case, I think it might actually be fine, but is actually for the beacon chain, it might not be too bad, but especially once we go into the shard chains, there's going to be a lot of clients that are running like 5 shards, 10 shards, and 50 shards, and so we want to keep in mind like what the marginal costs of being a validator on one shard are, and when there's trade-offs, like have a clear model of like what we think the cost is of a percent of CPU power versus a gigabyte of RAM versus a gigabyte of SSD, and like actually seeing whether or not it makes sense to go in some direction. Basically, because like it's like we do have an important task of making sure that running a validator is like marginally cheap, because it like if it's not, then it's going to significantly eat into validator profits, and which could both really hurt participation and encourage things like stake pooling. But it's like sometimes counterintuitive, like what actually is expensive and what actually is not expensive.
Yeah, something that I did in the benchmarks was bench on my laptop and on my desktop. It's quite interesting to see the difference between the two. It's starting to look like just the way that we've got it written. It seems like the more cores you have, it really improves the speed for you. So something to think about. If someone has like a 12 core or something, I'd love to see benches from it.
The other thing to benchmark on is probably like a minimal cost VPS. Again, I guess maybe we don't necessarily want to encourage people to stake on VPSs, but it's still like
still good to know.
Paul, if you have
good target,
if you have some code I can run like easily, I can give you benchmarks on my 18 cores.
Oh, 18 cores. Big fella.
Yeah,
actually, on the benchmarks docs, there's like a bit about running the benchmark. So I'd love to see it. You can just copy and paste the output if you want. Don't do the markdown table thing. It sucks.
Actually, the other kind of like I think we should really avoid the trap of running benchmarks on powerful hardware, because like we don't want to repeat the mistake of ETH1 and like having really high spec requirements. It would be good to get numbers on like the $200 laptops.
We'll try to run those on Raspberry Pi as well.
Yeah, sure. I've got some crappy laptops. I'll try them.
Cool. Okay, shall we move on? Yes.
Yep.
Thank you. If you haven't taken a look at those benchmarks, do. They're pretty exciting and cool to look through. Okay, the next up is leap seconds and time drift. I believe Justin added a note about how leap seconds is handled in Unix time and how we're conforming to Unix time, I believe. And so there were a couple questions on why and what exactly is happening there, and maybe a discussion on time drift in general. Justin, can you give us just a quick on that?
Okay, yeah, so basically we need some sort of notion of time in Ethereum 2, and I guess we have two options. One is kind of Unix time, which subtracts the number of leap seconds. So, and then there's this other thing which is much more esoteric, which is called the international atomic time or something like that. Now, I guess there's several reasons why we're favoring Unix time over this atomic time. One is that it's much more commonly accessible from programming languages. So I guess ease of use for the programmer is one thing. The other thing is that it's compatible with Eth1 timestamp. I believe Eth1 uses Unix timestamps. And the other nice thing is that it provides a nice invariant that at basically midnight UTC, the slot number is going to be a multiple of 14,400, I believe. So one of the things that we've done with Eth2 Genesis is to basically have the Genesis be at midnight UTC, and so this invariant would remain over time if we take into account the leap seconds. I guess by having this invariant, the trade-off is that we lose the invariant that every slot is exactly 6 seconds, or whatever constant we set it to in the future. I think this is the right trade-off to make, but I'm happy to hear counter arguments.
And to be clear,
I was just going to say that as far as programmer ease, I mean, like, at least a lot of us are just, literally setting 6-second timers and letting the slots tick. I mean, so that sort of surprised me when you said that we were accounting for leap seconds. So we're literally just going to have to use a system clock or something like that. Is that what you're suggesting here?
A timer without going back and checking some sort of system clock sounds dangerous and sounds like you would get much drift over time.
Yeah, like
right. Yeah, so that's why I asked about drift too, as well.
Yeah, like the kind of bug that I would see from like relying on just like doing timers without going back to a system clock is like, what if at some point you have your computer temporarily slows down a lot and it takes you like 19 seconds to verify some block, and then like does that delay your whole thing by 19 seconds? So like like a loop that says wait until, or some trigger that says wait until the system time hits like 6 times n, it seems.
Or even just if your computer sleeps and wake up.
Mm-hmm. Yeah. By the way, another nice thing about, I just realized, is that 14,400, the number of slots in a day, is also a multiple of 64. So it also means that we get like really nice epoch boundaries at midnight every time.
Just one thing, there is Linux 5.0 has started working on fixing a year 2038 bug. Which is basically because Unix time was using uint32, and in 2038 we run out of uint32, so we need to be uint64 right from the start.
Does this account for time sync attacks? Might be a stupid question, but what do you guys? What's the
by time sync attacks? Do you mean things like attacks on NTP?
Yeah, or like, let's say that I control a majority of the nodes and I say that 6 seconds, or my version of whatever time is, becomes like the standard.
So there's two kinds of attacks there that you have to unpack, right? One of them is an attack on NTP, and another one is a 51% attack, where the 51% attack basically kind of implements a chain that pretends that the time is, say, 2 minutes in the future.
Yeah.
So in the first case, I mean, I did write that Ether research post, and I talked about this at Stanford, I think, about network adjusted timestamps, which is basically like this hybrid between relying on local clock time and relying on like basically deltas between block or waiting sometime after messages that you see from other nodes. And I think if you just like Google for network adjusted timestamps Ethereum, you can probably find it. And like, I mean, this is both something that probably should be implemented. I mean, unless people come up with reasons why it's not a good idea or why there's something better. So I definitely like encourage people to read the post and possibly comment on it. The second, so that like the kind of practical effect of that is that it makes some NTP attacks not effective unless they're coupled with at least 33% attacks on the underlying system or on the proof of stake. And then as far as 51% attacks with that kind of push time forward go, that's not really like, that's not something like that is also something that exists with proof of work. And so we're not introducing any fundamentally new issues with proof of stake. It is like the kind of attack that's a bit more dangerous that I've thought about is a 51% attack where instead of being 2 minutes in the future, you're like 2 seconds in the future, and then you try to sort of pull a portion of honest nodes with you. And that is the sort of thing that probably should be analyzed more, but as I've said, it's like technically just as doable in proof of work as it is in proof of stake.
Okay, another possible solution is like implementation of like NTP v4, but I'll just like write something about it rather than boring you guys.
Does NTP v4 rely on some some trusted consortium, or like what's the security model basically?
No, I mean, but that's another thing is like if everybody needs to agree on time, then that needs to be somewhat of a function within the consensus mechanism itself. But what I was
so network adjusted timestamps kind of does that, but okay, go ahead.
Well, what I was thinking is like we could actually implement base functionality using NTP v4 within the actual like wire protocol. So when they're engaging in that handshake, you could actually use NTP v4.
And the trusted consortium being the validators.
Yeah.
I mean, that's actually like pretty close to what my network adjusted timestamp proposal is. Like, it's probably simpler than whatever the NTP protocol is, but it's still. Yeah. But that's just because like it doesn't need to have like millisecond precisions. And
yeah. Well, the thing is that this is NTP v4. This is something that exists now that we could probably easily implement in some sort of proof of concept to try to test.
Yeah.
So.
Wouldn't necessarily say that implementing NTP in the wire protocol is going to be easy because you need to. NTP has a bunch of mechanisms for accounting, for transfer latency and things like that. So just it's not just as simple as exchanging time.
Well, the wire protocol is kind of agnostic to that. As long as you're just accounting for what the definition of that message type is, then should be the responsibility of either the P2P stack itself or the application layer.
Okay.
Okay.
Okay, so just to sum up, we should just be using system time in order to determine our slots, basically.
Currently, yes, and currently using system time that conforms to Unix, which would adjust for leap seconds over time.
Okay, oh, sorry.
Oh, I mean, potentially an implementation might use some combination of timers and system time that make sure that they conform over time, depending on what you're looking for. But again, you need to kind of be going back to system time on some interval.
Okay, and then we're not so basically, and then Vitalik said that we're not concerned about some sort of NTP attack just because it's no different than what you might have in proof of work, right?
Yeah, like we don't have special reasons to be more concerned about 51% attacks that have to do with timing than we did before. But like we do want to we do want to take the timestamp problems seriously because proof of stake does kind of depend on timestamps more. So like if you can get people to believe wrong things about the time, you can cause you can wreak more havoc more quickly in proof of stake than in proof of work.
Okay,
But
yeah,
yeah,
that's what I was trying to wrap my head around. And then you said you had a post about
yeah,
this.
I think Justin said that he posted in.
Oh,
I mean, I'd encourage everyone to like read it and either implement it or come up with reasons why we should do something else. I'd be also curious to see if the Stanford people.
What are you up to?
I'm just rereading resources.
Yo, Greg, mute. Greg, mute. Greg, mute.
Sorry.
Yeah.
Just to comment on the implementation of the simulator that I did for the supercomputer, I implemented local timers for each one of the nodes, and so kind of simulating a Unix system. But I also implemented some kind of global synchronization every 5 seconds of this local timer, being 5 seconds a parameter that can be customized at the configuration of the execution. Yeah, so maybe this is some kind of combination that yeah, mixes both Unix time and global time. And I also observed some kind of weird things happening when the synchronization period is too long. Yeah, some weird messages from the future start to appear, and some things can happen. Yeah.
Interesting. So if you were relying on timers for too long, you started getting pretty out of sync.
Yeah. So that's what I set at this point for most of the runs. I set global synchronization of 5 seconds, assuming that most of benevolent non-attack nodes will have a maximum delay or time difference of 5 seconds, and that is also smaller than the slot time, and so that could allow the system to run more or less appropriately.
Got it. Thanks. Okay, cool. We're going to move on from the timing stuff. I skipped research updates. Quick research updates if we have any.
Yes, we have. So a few months ago, Nicolas posted a post on Eth Research P2P about using Quick for all peers communication. Is the new protocol initially designed by Google to improve on TCP and TLS. And we, in the last few days, we just replaced our UDP communication by Quick, and we wanted to see what will happen. And we saw like the performance degradation, which we expected, is because Quick does more things. It does the encryption and authorization, authentication by default, and also our like AWS instances are very small, so we are overloading CPU. But we didn't have bigger problems with integrations, and also we are using the Quick implementation by Protocol Labs. They are still working on it. There's this feature of zero round trip handshake, which we wanted to check, but it's not available yet. They are working on it. But we think this can improve also the performance.
Great. So, in general, positive or negative?
Yeah, I think in general it's positive. I think we can keep thinking about using Quick. The thing is that I saw that now we will have implementation in Go, and Google has implementation in C++. I didn't find implementation in other languages.
Right. And was the additional overhead on the the initial handshake of the protocol, or was the additional overhead on just continuous?
No, so the thing is that we don't do session management, so we handshake on every packet. That's why I think this is the main reason for the performance degradation. Yeah.
Gotcha. Okay, thank you. Any other research updates?
Would research updates include like spec kind of writing? Yeah. A couple of kind of spec formatting issues that came up. One of them is it turns out that we're doing shuffling in kind of two different ways, at least as it's currently written in phase 0 and in phase 1. And the distinction is basically like, is shuffling a function of like as in like the integer going in being the role and the integer coming out being the validator performing the role, or is the function that the input is the validator and the output is like the index of the role that it's performing? Like, because in phase 0, what we're doing is we're shuffling and then splitting the shuffle, which basically says validator indices go in and roles come out. But in phase 1, we're using get permuted index, which basically says that roles come in and validator indices come out. So again, like it would be good both for kind of cleanness and for just general total complexity reduction to agree on one or the other.
I would err on the side of doing what phase 0 is doing, unless there's a clear argument one way or the other.
Phase 0 is a bit it's kind of less elegant in that like we define get permuted index and then we define shuffle and then we take a slice of shuffle. So in some ways the spec as written kind of combines two inefficiencies in that it doesn't get the inefficiency from doing shuffle with the optimal algorithm, and then it also has inefficiencies because you're doing a complete shuffle and then taking a slice out of it. So like I personally actually find like it's not just the kind of forward versus backward thing. It's also just about the kind of aesthetic of whether you want to do a shuffle and then take a slice versus do you want to call get permuted index for a range of indices. I'd argue there's like aesthetic reasons why the get permuted index for a range of indices approach is might be cleaner too, but
yeah, I see that.
Yeah, we don't need to decide this now, but there's kind of two issues that are in the specs that are related to it. I think one is 729 and the other is, I think, 774, but I forget the exact number. Yeah, it's 774 and 729. Another spec formatting thing is that when we actually, and after this, I'll get to a real research update. We're doing hash tree like currently in a lot of places we're doing hash tree roots taking one argument, and with the kind of implication being that from the one argument you can infer what the type is. But there are some cases where you can't infer the type from the argument, and probably the most egregious one of those is lists, like because you can't distinguish between a static list and a dynamic list. So one possible solution to this is to just make it so that hash tree root just always consistently takes both an object and a type. The other approach is that we basically add wrapper classes for static lists and dynamic lists and apply them more consistently.
Yeah, and this is more probably on the Python side than anything, because a lot of these languages are going to have that some sort of internal distinction in their typing anyway.
Yeah, and it's I get the feeling that languages other than Python are probably going to take the one argument approach because everything is statically typed. But this is also just kind of for spec consistency.
Right. Yeah, I think it might make sense to wrap it up.
Yeah. Okay. So the real research update after like after spec nitpicks is the number 766. So this is the a pull request adding light client related files. So the idea here is basically, I mean, this includes a couple of different kind of new ideas. One of them is the concept of a Merkle multi-proof, which is basically a theoretically optimal way to combine, basically make a Merkle proof for multiple objects. And it's like this potentially has something like, it's somewhere in between like 20 to 30%, or potentially even more efficient than just having Merkle proofs for separate Merkle proofs for every value. So the idea basically is that whenever you have a Merkle proof and the Merkle proofs are kind of redundant and share hashes, or one of the hashes can be computed from the other hashes, it removes all of the redundancy and it just includes the minimum possible data that you need to compute everything. And code complexity wise, it's actually really not hard at all. There's there's both the light client spec file, and then there's also a GitHub research repo that talks about, and I put it in the Telegram, that just makes a minimal implementation of creating and verifying multi-proofs in 50 lines of code. So that's the first thing. And then the second thing is that basically there is an algorithm called get generalized indices. And the idea here is that you can represent an arbitrary SSZ hash tree. So an arbitrary, like a hash tree of an arbitrary object that you use to compute the hash tree root as a binary Merkle tree where the depths in different locations might be different. And so you can represent a path. So a path basically being a function that says, oh, given a block as an input, return the public key of the 197th validator, or return the length of the list of open challenges, or something like that. So it takes a path and it turns it into a kind of generalized index in the Merkle tree, which basically says like, where do you go left, where do you go right, kind of how deep do you go expressed as a number. And from there, it becomes really easy to just basically make a multi-proof of multiple accesses of kind of arbitrarily deep accesses in going into SSE objects. And this makes it just really easy to kind of define light client protocols for basically determining the minimal, creating minimal SS kind of Merkle proofs for calculating any kind of function that you might need. So like an immediate example might be if you want to calculate some persistent committee, if you want to calculate some like previous state root or some previous index root or something like that. And then there's I also introduced this notion of a Merkle partial, which is basically a kind of set of Merkle proofs that you can then use in place of an SSE object and kind of treat as an SSE object. So the goal of all of this is basically to have a basic framework that you can use to do pretty much anything that you might want to do with as a light client. And then the other file so this is all still in merkleproofs.md in 766. And then the other thing in there is sync protocol.md. And that basically describes a beacon chain light client syncing protocol. And the idea basically is that if you have some block header that you currently recognize as the head, from there you can ask for a Merkle partial, which tells you what the earlier and what the later persistent committee is. From there, you have a function that you can use to compute the shuffled committee up to some points in the future. And then from there, you can ask for future block headers, and then you can verify future block headers by basically verifying the persistent committee. And the data complexity of this is something like about 80 kilobytes every 9 days, plus a couple of 100 bytes for a block. So it's actually really nice. And it does depend on like one small patch that needs to be included into phase 1, which is basically reducing the persistent committee size, but actually it doesn't really require anything else.
Great. And to be clear, some of these protocols require some of the functionality from phase 1.
Yes, so the light client protocol requires the functionality. So one of them is just calculating the persistent committee. And by the way, just to kind of explain why, the reason why it uses persistent committees is because they change only once every 9 days instead of changing every epoch. And so the verification of a committee, which is what takes 80 kilobytes, only needs to be done once a week, and you can amortize it over the week instead of like having to do it every 6 minutes. And now and the other thing that you need is you actually need attesters to be kind of acting as members of persistent committees and signing some kind of shard block. So if we decide we really care about light clients, then we could implement a kind of minimal version of phase 1 that just basically gets people to keep on signing signing empty shard blocks, and that would give us enough. But like phase 0.
Vitalik, I think
Yeah,
you
I think
cut off.
Vitalik, you cut out. Anyway, Vitalik, you cut out.
Yes.
You said you think.
Oh, sorry.
You were talking about phase 0, phase 1. Yeah.
I stopped by saying that basically it does require a kind of minimal stubby part of a portion of phase 1, which is like some kind of shard block header structure. Like even if the data is empty, that's fine, but shard block headers need to exist and people need to be signing them.
Mm-hmm. And they need to be cross-linked.
No.
But okay, then they need to be able to be served.
Yeah, I mean, they need to be available over the peer-to-peer network.
Okay. Gotcha. Okay, thank you.
Hey, Vitalik, so I was looking at the composition of a block right now. Is that there's a beacon block with a header portion and then a beacon block body. In the wire protocol that was proposed recently, there's a mention of a beacon block header, which is actually not defined or specified anywhere else. And it says it's for light client friendliness, so it's possible for people to propagate block headers without having to do too much. I kind of like this approach because it's really easy for me to just get the bytes of a bunch of headers and just propagate that to a network. So replayability on the network level is pretty good. But you have a different opinion about how to go about that.
In the dev branch, there is a beacon block header defined, which is simply the beacon block, but instead of serving the body, it's serving the hash tree root of the body.
No.
Okay, dev branch?
Yeah, I can't remember if that's in master right now, but that's to be released in the V050.
In the light client protocol document, I also define a more general notion of an expansion and a summary of an SSE object, which is basically the idea that given an SSE object, you can create another SSE object where parts of the object are replaced by their hash tree roots, or where alternatively where hash tree roots are kind of replaced by the thing that they stand for. And like part of the reason why that's useful is that lets you talk about like an object that's part of the state that's part of the block, even though like as technically written in the protocol, blocks don't have states, they only have state roots.
Right.
All right.
Yeah.
Okay.
But like the light client thing is definitely like still very open to feedback, so I'd encourage people to like read through it and offer any comments.
Right.
Well, I mean, my biggest thing is validating and all the block, getting proofs and all that. That'd be great, but I think the first version of a client, a light client, if it just did a good job at replaying blocks and headers of the network, and maybe having a way to just consult 4 or 5 different peers to make sure it's not serving garbage, would actually go a long way to make the network more reliable by, you know, just getting more replayability between the different clients. That's all I have.
Yeah, makes sense.
Okay, we're ready to move on. Any other quick research updates?
So the quick research update I wanted to share is basically an improvement to the challenge game in the custody bit scheme. So the custody bit scheme, basically in the optimistic case where there's no challenges, basically you get this for free. It's just 1 extra bit in the attestations, and it's really, really nice. But in the worst case, there's this challenge that happens, and it turns out that this meant that the phase 1 spec kind of grew much more complex than we would have liked it. So the good news is that we have a new challenge game which drastically simplifies the communication complexity when a challenge happens, and it is looking like we can basically have a challenge which is just a 2-step thing where there's a challenge and a response. So it's like a single round of challenge response, which will allow us to do things like simplify the way we do incentivization and the way we, I don't know, handle the mechanics of the challenge. So hopefully that will allow us to have you know, the phase 1 spec be as simple as we want it, and hopefully I'm thinking on the order of 4 to 8 times simpler than the phase 0 spec. We've also made kind of a bunch of progress ticking off kind of the laundry list of small design points that are listed in issue 675, and hopefully for V0.6 we'll have almost all of these checked off.
Great, thanks, Justin. Okay, next up, I'd like to talk about the, or give us a chance to talk about the network spec. I know so Matt Slipper posted an PR on the specs repo, and I know that's very active right now, so if the conversation's mainly happening there and there's good feedback there, we don't need to go into it too deeply right now, but I did want to give just a second, a minute of time if anybody has some quick comments, questions, feedback, etc.
I think there was an active question about the use of Secchio or TLS 1.3 in networking in general. We might want to address here too.
Right. Zach, was that your question?
What? No. Well, yeah, but we started working on a kind of like just building out a lightweight proof of concept type of wire protocol. We're calling it Hobbits, or there and back again. The idea is to kind of just create something that works right now, and we've just about finished implementing it. Matt's working on that with me. Antoine is as well. There's like a few people that are contributing to it right now. But I just wanted to kind of get you guys' feedback and like see what you think about that thing. Matt, do you want to talk about that?
Yes, sir. Sorry, I had to find the mute button. Okay, so did you link the repo?
No.
Okay, let's just link that file. Okay, so we're just hearing a lot of feedback from people creating the clients that there's not a lot of activity going on as far as like testing peers talking to each other. And I know that there's a lot of work going on libp2p to figure out a lot of things regarding finding the peers in different parts of that higher level network stack. But a lot of these are like maybe in the application layer, details of the application layer. So we were thinking that maybe there should be like a different layer at the bottom, which is just like a simple wire protocol, which is extensible enough to allow people to start iterating and start communicating. And so what we've done is I've created a EBNF grammar, which is basically, it's kind of like sort of inspired by HTTP, but it's very, very minimalistic and narrow to the use case of sending like binary payloads in an RPC manner. I looked at the specification. I can't remember, what's the name of that other serialization library that's going on, Zach?
What, SSZ?
Yeah. Okay, so there's SSZ going on, right? So SSZ.
There's also SOS, which is this like proposed alternative.
Right. So SSZ, as far as I can tell, is basically very, very similar to BSON as far as the types it supports, but it has this additional tree hash type. And so my concern there is that's moving in a direction where you're sort of you're putting application schema into the protocol, and you're making it sort of one monolith. Now, over time, the types of data structures that might need to be supported will evolve, and it's just nice to be able to negotiate some of these things if you have to iterate over time with different clients that may not be at the same level of being up to date. So what we're thinking is BSON provides the basic primitives you want, like integer, float, things like that. But what you get is also a binary data structure, and inside these binary data structures, which can be tagged as like field names, you can bake in your SSZ if you really want to, or any of your like actual application specific data payloads. But I don't see. I think it's dangerous to kind of go in the direction of baking your application logic into the wire protocol itself, because it makes it much harder to evolve and negotiate between different capabilities within the clients.
I'm curious, like, what do you mean by baking application logic into the serialization protocol here?
So like there's this tree hash that's in SSZ, for example.
Yeah, so tree hash, I think like it's definitely a misnomer to call it SSZ tree hash, because honestly, SSZ and tree hash are both like functions of the same kind of data structure, but like you can totally swap SSZ for something else and keep tree hash exactly as it is.
Right. So there's a lot of experimentation that probably needs to go on in what the most optimal pickling format is. But in the meantime, maybe we can get rolling faster if we have a simple wire protocol and figure out the data structures as we're iterating, instead of trying to specify the protocol completely up front.
By the protocol here, you mean the wire protocol, like not the consensus layer, right?
Yeah, totally. The wire protocol is, let me be clear, my definition here is the wire protocol is responsible for making a common agreed upon messaging format, which can support basically RPC type commands. And it's like a lot of this is getting conflated with the whole libp2p thing, where it's like that's going to solve everything, so everything's just going to be implemented through that. But that makes it, it's like it could be very simple. It's like, oh, all you got to do is parse this simple thing, and here's an EBNF grammar, so it's like easy to understand what to do, and you can start interacting, as opposed to having it's just like, oh, well, you have to just install libp2p. I don't know if this doesn't make any sense.
Oh, go
ahead.
I was just gonna say, so like libp2p, devp2p, all those P2P stacks are really designed specifically to accommodate for the application layer. The wire protocol should be something completely separate, like RLPX, stuff like that is kind of just a mechanism to establish a handshake and kind of define the rules of engagement for communicating with those peers. And then layers on top of that are responsible for adding additional logic to how those messages are formatted, all of that application logic that says like this message means this. The wire protocol should be like a dumb protocol that's kind of agnostic to any of that additional logic. So if that makes sense to you guys.
What additional logic are we talking about, though? Like, I'm still not.
Well, like all of the negotiation for like how particular messages are going to be interpreted, or like what the like pickling format is going to be, etc.
So we're saying wire protocol should be independent. Like, we should be able to like change the wire.
Yeah. So
protocol.
all that matters is that we have these messages and these bytes, right? All that matters is that each client agrees that this particular byte sequence correlates to this particular action or application logic. The wire protocol itself doesn't need to account for any of that. So it should be lightweight. We shouldn't have to worry about TLS. We shouldn't have to worry about like any of those additional features. You know, like those are just going to bloat the protocol itself, and it's going to take much longer to try to get something out that's actually functional. We should just have something that's like the bare minimum and try to prevent like, you know, let's like follow the Unix philosophy of design and kind of just like make something that's simple, functional, and versatile enough to accommodate for future.
So the reason why I'm confused is that like SSZ by itself is pretty simple and versatile, and like SSZ as a thing doesn't really depend much on like application level decisions at this point.
I think the idea is that we might want something other than SSC, or we might need to expand beyond SSC. So don't bake any of that level of the encoding into the wire protocol, and the wire protocol essentially just represents messages as bytes.
Right. And right now, if you look at the wire protocol,
that's to say this is an SSZ message, or this is a BSON message, or whatever.
Hey guys, have you guys had a chance to look at the discussion around the like wire protocol that's currently PR'd against the specs repository?
Have we?
Yes.
We've been trying to look at all the different stuff that's lying around.
So,
but
okay.
Oh, sorry.
Yeah, because there might be some confusion here. And the wire protocol for the current like network specification is effectively just SSZ. But the reason why, like, if you look at for example, there's a messaging specification, and it basically just has a version bit that represents your compression protocol, your compression scheme, your encoding scheme, and then some encoded body that can be SSZ or whatever. The fact that we're using libp2p does kind of matter here, because that's going to determine the way that we negotiate which compression and encoding formats we're going to be using.
Right. That shouldn't be on the wire protocol, though. That's an application layer decision.
Well, your wire protocol in that case, right, is just going to be whatever the negotiated format is. Like in any world, the wire protocol for an RPC call, for example, right, just needs to describe what data structure are you sending over the wire. Yeah. Whether you're negotiating up front for, you know, to use SSZ or not, happens somewhere else. But the fact that we're using libp2p means that like we need some place to define where that negotiation is going to happen, and so. Effectively, all the like RPC like specification is saying is these are the data structures that are being exchanged, and here's how you can find out whether or not like they're encoded using SSZ and how they're compressed. Like that's it. Like I think it's easy. It's easy to like. It looks, I think, a lot more complicated than it really is. All it is just effectively one libp2p protocol ID that's used to identify messages that perform RPC calls. That's all it is.
Mm-hmm. Yeah.
Okay.
One thing, maybe in terms of organization, should the people working on the wire protocol maybe have a call every week so that we only have reports on the conclusion during the Ethereum 2 implementer call, and also to prepare for EthCon, because I suppose Danny will have a workshop on that.
Yeah, so we were talking about starting a working group. So I mean, there are about 8 of us working on this stuff right now, and I mean, rather than like kind of like, you know, duplicating any efforts, yeah, we should probably just start a working group that we can all contribute to and discuss these things together.
Yeah, that's fine with me. Just let me know. Yeah, the best way to contact y'all. Are you going to be at EdCon as well?
Yeah, we'll probably be at EdCon. I don't really want to travel, but yeah. I will likely regrettably be at EdCon.
Felix,
Okay, cool.
I've seen you unmute like 8 times. Do you have a comment?
Yeah, I just didn't really know how to when to jump in properly. So I just wanted to quickly circle back to that earlier question of like, can't we just have like a simple sort of protocol like that? That's the thing that originally kind of got me started. But then you guys already kind of reached a like reasonable conclusion. So I guess what I wanted to say is that basically I've voiced this concern many times, is that basically I think that it's totally fine to represent consensus objects whenever they're transferred using SSE or any other serialization format, but
Yeah.
that might actually be the best choice to encode, say, like the message frame that carries the RPC command or anything like that. But it can totally be used though, and I think Matthew is kind of right in saying that at the end of the day, it does matter a bit that Eth2 is relying on libp2p because that already defines how these RPC commands are encoded on the wire and things like that. So I think that the high-level wire protocol specification for Eth2 really only needs to include the names of these RPC messages and then their sort of like payload and how that's encoded. And I think that's pretty much what it does. So it is kind of all right now.
Yeah, so I just wanted to mention a few more things. I didn't have a chance to finish. So the wire protocol that we specified, we would like some feedback on it. But the thing is all it really is responsible for right now is like Anton was saying, identifies the name of the command, negotiates compression, and then there's 2 separate headers and payload. These are just basic protocol optimizations. If you put everything in one serialized payload, like in one SSC, then that means that the whole thing has to be pretty much decoded before. Maybe you can partially do it, perhaps, but still, like you have to do a lot of work to like look at partial or the whole thing. And so these little optimizations in protocols where you have in the first 10 bytes or first 20 bytes, all the information you need to make a decision sometimes makes a huge difference because you don't even have to deserialize the payload. So,
but that's exactly the issue we had with RLP and why we wanted SSZ, where we could put, or maybe the offset serialization, where we could know at which offset was the data we needed without deserializing everything.
Yeah, if you know the SSZ, the frame that contains the RPC message just has an ID and a method name, and they're both like SSZ objects, so you can look up the offset.
To read all those bytes. Like you have to read all those bytes. Sometimes you don't need them all, if that makes any sense. Like,
so you might as well just look into so we've been doing like on the dev P2P side, we've had like streaming messaging and all these things like for kind of a long time. And I can kind of tell you that we haven't actually needed it very often. So we do it in Go Ethereum in the dev P2P implementation. The way we handle it is that basically all of the message decoding is streaming. So we process, basically we only deserialize as far as we need into the message to really figure out if it's valid and stuff like that. And that hasn't actually bought us like any extra speed or anything. So I wouldn't necessarily say it's like super important to have that right now.
That's
One
good.
other thing, like right now, isn't everything sort of tied to libp2p? Like Eth2.0 protocol is libp2p as far as I can tell. Like,
totally.
Yeah, that's a longer point I would want to make, which is there is an excellent PR from Matthew Sleeper on some RPC method that would allow exchanging data between clients, and they require RPC level methods and some intent behind them. But that it's actually being pointed in that document in one of the comments that gossip would be used to propagate blocks and headers, and that seems to be kind of the magic bullet that people just want to use for libp2p propagation. I don't know that is going to be such a great way to do it, and I would want to see better flows on actually what the life cycle of how you would want to propagate blocks and headers to other peers, and how would we be mindful about that. And those actually would have to do with the rest of your domain lifecycle and your consensus and your block time, right? Because depending if you're pushing or pulling, depending how fast we can see propagation in the network, the block time of 6 seconds is going to be interesting, right? So we need to be the performance of that networking layer is really, really critical, and maybe even so than some of the the tricks you can play with hashing and all that. And I think so one thing that the Hobbit protocol does is that it does not really enforce encryption, for example. So you can really replay a message between two peers by just getting the bytes and just take this message as is and just push it to another socket. So if we're talking about gossip and just making it really noisy, we could do that. And it's kind of, because it's bare bones, it's more open to iterative development and changes, where most of the updates of this code so far have been people trying to implement libp2p in a fashion that they can leverage it. So
yeah. Another thing I wanted to note is
libp2p is such a huge vehicle. Yeah, go.
No, I don't want to interrupt. Sorry, continue, please.
It's just tying yourself to libp2p roadmap makes it that you're going to only deliver after libp2p is done, right? There's nothing new here. It's just software engineering.
So I guess it will be really beneficial at this point to just get together and find this like minimal, insecure, unencrypted wire protocol transport mechanism that allows you to do cross-client testing. And I think this is something that, you know, the Eth2 implementer community should look into actively to just kind of make something work. It doesn't have to be perfect. It doesn't have to be the world's like best and most secure and most optimal transport. You know, it can just be something where basically you could do basic interoperability testing, maybe run like a test net, and that's totally going to be fine. And then, you know, there's going to be so much time later to figure out what the actual perfect transport mechanism is. And you know, there are literally like hundreds of options available for that, and I don't think it's like the right time now in the implementation cycle of Eth2 to worry about what the final transport protocol is going to be, or what the final sort of, you know, discovery mechanism is going to be, because basically we're all just, you know, chewing away at our own sort of like, you know, favorite optimization topics. But, you know, at the end of the day, what really matters now is just, you know, getting the clients to talk to each other.
Yeah, so what I wanted to, thank you for saying that. That's exactly what I was going to try to say. Like what we're not trying to presume that's going to like override any existing work or anything. We want to get something out the door very quickly that'll allow us to actually start doing network testing and getting clients to talk to one another rather than operating on these like simulations and these like monolithic applications. This will help us push the ball forward. It's something that we can implement like before the next call. Like we're already working with the Artemis team to get this working, and we're speccing it out, and we can have this functional. We can have multi-client testing much quicker by doing this, and just, you know, like, let's just start building, you know.
Yeah. So this is also something that this is also some lesson learned that I can share from, you know, the development of ETH1. So the way that ETH1 was developed, that throughout the entire POC series, there was no RLPX, there was nothing. We had all we had was like unencrypted TCP connections carrying RLP, and that took us like really, really far. And then we only added encryption, I mean, in just, you know, like kind of late before the launch. I mean, we haven't been super happy with RLPX. It's kind of a, you know, shitty protocol for, you know, most people who've actually looked into it will know, but it's definitely, you know, something that, you know, got us really, really, really far to just to find the most minimal thing possible, and then you know, take it from there. So I think this is something that I would really like to see, is just to have this like super basic protocol that you can implement in like 3 days. And
yeah, I love you. Thank you.
Any more comments on networking right now?
So maybe it's good time for me to give like my usual update about the whole discovery stuff. Is that
yes, please?
So not super much has happened. So I've actually not really been busy with discovery last 2 weeks, because we've tried to push the ETH version 64 discussion forward. So that is something that mostly concerns ETH1, and you're gonna maybe hear about it tomorrow in the All Quarters call. We did revamp all of the ETH1 related specifications. So we have a really, really good specification of the ETH protocol and a sort of complete specification of the ETH1 like client protocol right now, but that doesn't really mean anything for you because you're all working on ETH2. And when it comes to the discovery, what kind of happened is that I am still implementing discovery version 5 as sort of specified, and the specifications live in the repo. And we've had a pretty annoying issue where basically, since the whole thing is supposed to support like different sort of kinds of node identity at the same time, we kind of have to find a way to verify package signatures on the individual UDP packets, sort of like depending on the crypto system that the individual node uses. And currently, there's no super good solution for that. So there is an issue open on the DevPDP repo that kind of tries to explain the problem. And if anyone's interested in, like working out fun UDP crypto problems, then, you can come there and help out. Otherwise, we're probably going to have a solution in time for like the next call or something. I don't know. So that's the current update. So started implementing, and we're starting to hit like the first sort of like real world issues with the whole thing.
Great, thank you. Okay, on networking. Yes, there's value in getting some of these minimal protocols out. And if a team or two want to drive that forward and want to begin experimenting with interoperability in that respect, go for it. I don't think that clients should experiment with interoperability on the wire until they're conforming to state tests, which I plan on releasing today, but for v05. That said, we're going to continue to work on a more concrete high-level spec in parallel to some of these like rapid iterating smaller specs.
Yeah, I mean, don't let the size of the spec that I wrote sort of like scare you. I guess like all it is just SSZ through a libp2p protocol. That's kind of it.
And from that, if you want to work on something more minimal, look at those message types, look at those RPC communications, and just build them minimally. Because those are at least in the direction of what is going to be required for the communications protocol. Okay. Piper has some serialization benchmarks that he wants to share. I think I linked to it just recently in the agenda. Piper.
Cool. This will be short. I'm glad that there's other people working on the actual wire protocol part because other people are more knowledgeable than me on that. I just have been like digging into serialization and sort of at the more at the application layer, but with thoughts towards the network layer. And I ran a bunch of benchmarks, and there's data that you can go look at. It's pretty extensive. But the gist is that RLP is actually really terrible for ETH2 data structures. It almost doubles the size because of all of the little link prefixes and the deep nesting of things like blocks and even attestations. And essentially, I've just been looking at SSZ, which is, I think, actually an old version of the SSZ spec. I've got my own sort of really highly tight, compact serialization format that I've been tinkering with. And I've also been reasoning about SOS, that style. And I think it was interesting what Felix said earlier about rarely actually needing to index into some of these data structures. However, what I'm currently leaning towards, and I do not feel like, I don't know enough about this yet to have like a really strong opinion, but where I'm leaning right now is pushing to modify the SSC spec to include the SOS style offset pattern so that we can have a serialization format that also works as a contract ABI. And I believe that at least those two things combined together give us reasonably compact messages that can also be used to talk directly into contracts that give us that fast indexing into data structures, which at the application level may not be useful, but inside of the context of like the EVM or any sort of like, and I say that in the most generic, like EVM, EWASM, whatever, being able to reach into these things and grab the data that you need in those contexts is actually useful. Like Vitalik said earlier, tree hash maps well onto the top of just about any of these formats. And then the last thing that I'll say is that some experiments with SSZ suggest that there's maybe 9 to 10% size gains that can be improved, but it's reasonably efficient from the get-go. So even as, like, not as the wire protocol, as in like what we were just talking about, but as like the inner part of it, I think it's an acceptable format, but we could still get message sizes down by about 10% with some slightly different ways to compact things. I'm happy to answer anybody's questions, but I'm not at a point where I feel confident that I just know.
Just on the method itself. So, how do you do 9-10%? Is it time based or?
Size. So resulting size, like 9 or 10% size reduction in overall messages. Similarly, but to get that 9 or 10%, you also gain the ability to do streaming, encoding, and decoding, but you lose the ability to dynamically index into a data structure without decoding it, at least all the way up to the point where you're indexing. So there's trade-offs across the board here.
Just a comment on your document, which looks fantastic. You said problem statement. When talking about serialization, we need to be looking at two primary use cases, networking and protocol.
Yep.
I think you should rename protocol to consensus, because that's what we've been using in July when we were talking about serialization, because those serialization come up like every 2 months. Someone says SSZ, protobuf or whatever, and we use consensus.
That's a much better name. Thank you. I like it.
Do you know about the CPU utilization when you do that? Is there a big CPU difference between the different methods you have?
I suspect that the more compact version is less CPU intensive, assuming you're decoding the whole thing, just because it includes less information. But then again, so one of the primary place where these size gains are achieved is using LEB 128 encoding for integers, which just dynamically scales the size of the integer. And now that I'm saying this out loud, I suspect that there's some CPU hits there because you actually have to like iterate across each of the integer bytes until you find the one with the high bit set. And so there's going to be some performance hits there while decoding, but I do not know what they are. I will start looking into what the difference is.
Okay, take a minute to review Piper's excellent document. It seems like making some modifications to SSZ to accommodate for it being more useful in the VM makes sense. Okay, we are at the end of the call. We are meeting in person for whoever happens to be in Sydney on April 9th from 9 to 5. I will share location. I'm going to send a doc around so we can get a head count and figure out what we want to work on that day. That is the middle day of the hackathon, so we won't miss the opening or closing ceremonies, and then the actual EdCon starts the 11th. Usually we have time for any like spec discussion stuff. I'm going to be dropping V05 today with some tests and can handle any questions in the Gitter as usual. So let's skip that today. All right, any just like quick closing remark, anything that needs to be said?
I think we just, we talked, repeating what we mentioned, we talked before, we like instinctively in favor of like having like class wrappers to separate static and dynamic lists so that they have like different Python types.
Yeah, because I think that kind of actually intuitively translates more over to these statically typed languages anyway.
Right. Okay, that sounds good. And we don't need to make any wrappers for numbers because it seems like so far we've been we've even made the validator balance decision in the direction of UN64 being the one true UN.
Right. Okay. Thank you.
I just had a quick
Yes.
note on the shuffling. So basically, we talked about time today, and the way it looks from our perspective is basically that we schedule a handler, and it looks at like what's the time now, and what do I have to do. So if we're changing the shuffling around, that's like the question that we have to answer, and we have to answer it in two ways. Like, what do I have to do right now, and what am I going to have to do in the future, so that I can prepare by, for example, syncing some shard, right? One thing there is that what I have to do now might change if my hedges, right? If we have these deep reorgs, so that's something to consider as well when selecting which side of the coin the shuffling, or which aesthetic for the shuffling we should use. Mm-hmm.
Right.
And
So,
it would be nice to have something in phase 1 and phase 2.
right. So does that way of looking at it imply one direction or the other?
It sort of implies the phase 1 direction, if I remember it right. Like, I have a slot. What should I do?
Right.
Yeah. The phase 1 direction is the input number referring to the role. So like which basically just means like which committee you're in, and the output being what's the validator that's responsible for that role.
Mm-hmm. Which can translate to here's a slot. What are the validators?
Yes, because like by role, I just there's a set of roles for a committee. There's a set of roles for a slot.
Yeah,
it's also
like gut feeling wise, just hearing it, that feels more natural. But
yeah,
you know.
It also has the advantage that I think we save like a tiny amount of hashing, because maybe something like 10%, because if we're calculating the committee members for some committee, then at least in the first few rounds of hashing, they'll be concentrated in like a fairly small set of ranges of the full validator set, and so the hashes you need to calculate for the shuffling are going to be shared. But that's like maybe a 10% gain.
Yeah, just as long as we also have a way to anticipate what we're going to do, in the future.
Yeah, we do. I mean, the nice thing is that the shuffling, the permutation algorithm is like trivially reversible, so not a problem.
Yeah. Well, then that's perfect. Yeah, cool.
Okay.
Yeah, like you'll literally do the exact same thing, but you just run the rounds in reverse order.
Well, maybe I'll mention one other thing. I talked briefly to Danny about this, but some of these invariants that hold across, for example, which are fixed from a finalized block, or which are fixed from a justified block, and so on in the future, it would be useful to understand those more clearly, which ones we can rely on to be maintained in the future. For example, the committee won't change for an epoch from the justified epoch. It's like we can reverse engineer that from the spec sometimes, but if they were spelled out, we'd be much more comfortable relying on them for optimizations and the like.
Right. So having the research team doing a pass on adding explicit invariants would be useful.
Yeah, exactly.
Cool. Agreed. Okay, we're going to close. 6 minutes over. Thank you, everyone. Really good discussion. V05 coming out today, and talk soon.
Thanks, all.
Enjoy. Thank you.
Thanks. Bye.
Thank you.
Thank you.
Thank you.
Thanks, everyone.